everyone. I'm Byung-Chul Chun. I'm working for Department of Preventive Medicine, Korea University Medical College. It's my great honor to have a chance to present at this KU-UCI conference. Today, my topic is the epidemiology of COVID-19 in Korea. I will also talk about some aspects of global epidemiology of COVID-19 to improve understanding of Korean situation. Actually, I have two parts in this presentation. The first one is epidemiology of COVID-19 in the world, and the other one is in Korea. I will talk the estimation of epidemic parameters, transmission probability, and spatio-temporal characteristics of COVID-19 clusters in Korea. In the part of global epidemiology, my primary concern is what makes the difference of incidence and mortality of COVID-19 across the countries. As all of us know, COVID-19 epidemic is ongoing now. About 62 million cases and 1.4 million deaths have been reported to World Health Organization at November 29th. And we know the progression and incidence of COVID-19 are quite different across the continents. In this graph, we can see the difference of the scale by scale for number of cases at first. And we can get a graph of similar shape when plot this graph with incidence rate rather than the number of cases. You can see the huge difference of the scale. And this map shows the incidence rate by country on November 29th. As you can see on the map, the incidence rate is high in Europe, North and South America, and seems relatively low in Asia and Africa. This map, as of August 16th, about 3 months ago, but the difference of the incidence between countries are almost exactly the same to recent one. These country-specific incidence patterns have remained largely unchanged since the COVID-19 spread around the world. If we compare the incidence and mortality by continents, we can see the difference is very obvious. America and Eastern Mediterranean area are the highest in incidence, about 90 times higher than Asian continent. For mortality, America and Europe has over 20 times higher mortality than that of Western Pacific regions. What makes this difference? So we started a study to identify the factors associated to this large variation of COVID-19 incidence and mortality across the countries. We selected finally 136 countries which have over 1 million population and at least 0.1% population was screened for COVID-19 among total 215 countries. We put the covariate into the model such as COVID-19 test rate, geographic factors, demographic factors, socioeconomic factors, global health security index, health indexes, and health behavior and chronic disease prevalence. And we also put the ethnic group or ethnic region, because our main hypothesis is the ethnicity or ethnic group may play a major role of this difference of incidence. Now the result. This figure shows the incidence and mortality of 136 countries in the study. You can see the strong association between the incidence and mortality. Korea is here, somewhat lower incidence and lower mortality rate. Now, this figure is for the association of incidence and case fatality ratio. The lower incidence of pink and blue dot represent the countries from Western Pacific region and Southeast Asia. On the contrary, in the highest incidence regions, you can see many green dots and brown dots, which represent the countries from Europe and America respectively. From the multivariate analysis, we found the ethnic region have strong effect on the incidence. You can see very high risk ratio in ethnic group of Latin America, about 51, and Europe and Russia about 37 compared to East Asia. And you can see the urban population also is a risk factor. And very interestingly, the number of physicians per 1,000 population is a protective factor. It is significant. And this model explains about 60% of the variation of the incidence, and the ethnic region itself alone explains about 45% of the variation. For the case fatality ratio, the ethnic region also strong predictor. The ethnic region was also strong predictor. Other risk factors included in the model are unemployment rate of the country, and you can see the education index and the number of physicians were preventive factors in this model. That is to say, the fatality ratio was low in countries with higher education levels and more doctors per thousand people. Okay, and what is the ethnic region or ethnic group in this study? This map shows the ethnic region in this study. For example, this area includes Korea, China, Japan, Vietnam, and Thailand, and etc. In East Asia ethnic group. The East Asian ethnic group shows the lowest incidence of the COVID-19 here. Sorry, the color is not matched. And for example, another example for Latin America and Caribbean area is the highest instance in this graph. We conclude tentatively that ethnic region influence greatly the crude incidence rate of COVID-19 globally. You can see the case fatality ratio is also highly dependent on ethnic group. Again, the Asians had lower case fatality ratio, but the Europe and North America have highest case fatality ratio. Ethnicity itself is a complex concept, and the ethnic group classification in this study is also very crude. However, there is no recognized social standards for defining ethnicity of a country. We define ethnic region by the major ethnicity and region according to the previous study. And why the ethnic region matters in COVID-19 instance? If this is true, there can be lots of plausible explanation to this. For example, the biological factors, cultural and behavioral factors, and regional factors, etc. We suggest in our manuscript that the biological susceptibility of East Asian people living in East Asia may be lower than other ethnic groups living in other continents. I think there may have been a similar viral outbreak in this East Asia a long time ago, and in this East Asia includes China. Now, part 2, I will talk about the epidemiology of COVID-19 in Korea. This graph shows us the outbreak in Korea. There are total over 33,000 cases and over 500 deaths. The orange line represents the number of suspected cases, and the blue bar here the blue bar represents the confirmed cases. We can see there are three big peaks. One is the specific church cluster in Daegu and Gyeongbuk area, and second one is the metropolitan outbreak in summer, and the third one is ongoing all over the world. The incidence is slightly higher in female than male, and by age group, the age over 50 years old have a higher incidence than other ages except the 20 years of ages, which has highest incidence in Korea. The case fatality ratio is highest over 80s, and it is abruptly increased over 60 years of age. And I made a timeline of COVID-19 outbreak in Korea and marking some big clusters here. This number represents a cluster with more than 100 cases. So from January to August, there are about 12 big clusters in this outbreak. I also summarized the Korean government's effort to control the outbreak in this map, including so-called 3T strategies, that is test, trace, and treatment. For the test, we developed RT-PCR diagnostic kit and expand the test capability rapidly in the early stage of outbreak. For the trace, we made a contact tracing system with high ICT technology. There are two basic parameters which determine the epidemic: the basic reproductive number R0 and the mean generation time. Estimation of these two parameters is essential to control and predict the epidemics in any countries. To estimate the R0 of COVID-19 in Korea, we had to reconstruct the epidemic curve from the bottom. We got the epidemiologic investigation data from Korean CDC and made an epidemic curve based on symptom onset days. This graph shows the difference between epidemic curve based on confirmed data, which presented by the government, and the epidemic curve based on symptom onset data we have constructed here. And yes, R0 should be calculated with the epidemic curve based on symptom onset date. The average R0 in Korea was estimated 2.1. Some regional specific church cluster shows highest R0, over 2.5. That is about over 65% of people should be immunized to get herd immunity in Korea. We estimate the serial intervals of COVID-19 in Korea using about 1,600 pairs from contact tracing data. Interestingly, the estimated serial intervals are getting shorter and shorter as the outbreak continues, because the case definition for screening have been changed multiple times during this period. But the mean serial interval was estimated for days. The serial interval have the ranges of 2.6 days to about 8 days, with mean of 4 days, and it depends on the characteristics of confirmed cases. Also, we had a chance to estimate of transmission probability of COVID-19 in Korea. We used contact tracing data of about 50,000 persons who contacted with about 5,000 confirmed cases, we found there was significant transmission 5 days before symptom onset. Especially the family members are vulnerable to be infected this pre-symptomatic period. The overall secondary attack rate was 3.3%, and it is high in female than male. And also the secondary attack rate is high in old age group. However, the transmission is highly dependent on the places where the transmission occurred. As we expected, this disease, COVID-19, formed regional clusters easily, and we identified total 24 regional clusters from January to July. These three maps show the local clusters in each epidemic phase 1, 2, and 3. We found infectious disease security index of a county is a significant predictors of high instance of COVID-19. The high index means lower security and higher COVID-19 instance. And also the influenza vaccination rate is significant as preventive factors. And we estimated the odds ratio of regional risk factors for formation of COVID-19 clusters which have over 20 cases. The age of the region was a risk factor, and high influenza vaccination rate and high family income were significant preventive factors for making regional big clusters in the region. And now the conclusion of global epidemiology. COVID-19 incidence and mortality vary widely between countries. We found ethnic region or ethnic group could account for a considerable portion of the incidence and mortality. East Asians are least vulnerable to COVID-19. However, there are many factors should be considered in the model, and further research is needed on which factors of the ethnicity makes this difference. And the conclusion of epidemiology of COVID-19 in Korea. COVID-19 can be spread 5 days before the onset of symptoms, so contact tracing should be included this period. We recommend at least 6% of the population should be immunized to form herd immunity to end the current epidemic in Korea. The secondary rate was about 3.3% in total. However, it was higher in the elderly, and the asymptomatic infection rate was high in the younger. So, development the control measures appropriate to age-specific characteristics are needed. And the last slide. COVID-19 easily forms infection clusters, and the size of the clusters or maintenance period is determined by the place of clusters and the characteristics of the population of the clusters. It is necessary to identify high-risk areas based on local risk factors and to establish different priority depending on the risk levels of the regions. But there is still much to be learned about COVID-19 epidemiology, and more public-private partnerships are needed for the study. Thank you for your attention.